Hello again. This is Math 2231 coming to you from the College of DuPage, and the title of this lecture is Heron's Formula Conclusion and Zeno Reset. As always, please be attentive listeners while watching this video. By way of introduction, a previous video provided the proof of Heron's formula, and this was posted. But that video did not complete the calculation I asked you to do with Heron's formula, so this video completes that task, and that means that the learning from LSA 1 should be complete. Moreover, at the conclusion of last class meeting, several students indicated they did not capture LSA 2 in their notes and consequently felt compromised by the Labor Day deadline. Accordingly, this video recovers the statement of LSA 2, and I have relaxed the deadline to the Wednesday after Labor Day, which is 9/7, and so you have more time. And finally, in response to some other student questions, we again reviewed the turn-in process for the LSAs. So part B on LSA related to Heron's formula, we had a triangle where the sides were 9, 8, and 7. That means the semi-perimeter, when you calculate it using this formula, is 12. So the area, according to Heron's formula, is going to be the area is equal to S times S minus A times S minus B times S minus C, and the square root of all that. So we put in the numbers, and we get the square root of 720, which is 12, the square root of 5, if you simplify it. So this completes LSA 1. Now we move on to the statement of LSA 2. And in class, some of you will recall we did read through this, but I'm reading through it again here for completeness. And this is called Zeno's paradox of the tortoise and Achilles. Zeno of Elea, who lived 450 years before the birth of Christ, is credited with creating several famous paradoxes, and perhaps the most well-known is the paradox of the tortoise and Achilles. Achilles was the great Greek hero of Homer's Iliad, and many people have talked about this since then. So the original story goes something like this. The tortoise challenged Achilles to a race, claiming that he would win as long as Achilles gave him a small head start. Achilles laughed at this, for of course he was a mighty warrior and swift of foot, whereas the tortoise was heavy and slow. "How big a head start do you need?" he asked the tortoise with a smile. 10 meters, the latter replied. Achilles laughed louder than ever. "You will surely lose, my friend, in that case," he told the tortoise, "but let us race if you wish it." "On the contrary," the tortoise said, "I will win, and I will prove it to you by a simple argument." "Go on, then," Achilles replied, with less confidence than he felt before. He knew he was the superior athlete, but he also knew that the tortoise had sharper wits, and he had lost many a bewildering argument with him before this. "Suppose," began the tortoise, "that you give me a 10-meter head start. Would you say that you could cover the 10 meters between us very quickly?" "Very quickly," Achilles affirmed. "And in that time, how far should I have gone, do you think?" "Perhaps a meter, no more," said Achilles after a moment's thought. "Very well," replied the tortoise. "So now there is a meter between us, and you would catch up that distance very quickly." "Very quickly indeed." "And yet, in that time I shall have gone a little way further, and so now you must catch up that distance." "Yes." "Yes," said Achilles slowly. "And while you're doing that, I shall have gone a little way further, so that you must catch up that distance, the new distance," the tortoise continued smoothly. Achilles said nothing. "And while you are doing so, I shall have gone a little way further, so that you must catch up that new distance." And so you see, in each moment, you will be catching up the distance between us, and yet I, at the same time, will be adding a new distance, however small, for you to catch up. "Indeed, it must be so," said Achilles wearily. "And so you can never catch up," the tortoise concluded sympathetically. You are right, as always, said Achilles sadly, and conceded the race. That's the end of Zeno's paradox. So your LSA, I'm asking you to answer 3 questions, and again, I have adjusted this due date. This is going to be the Wednesday after Labor Day, and certainly you can upload it before, but that's when it's due. And again, this is take-home protocols, so you can collaborate, you can get help. You can go to the GSGs or the Learning Commons or my office hours. Anyway, 3 questions. Number 1, assume Achilles runs at a constant speed of 10 meters per second, and the tortoise runs at a constant speed of 1 meter per second, and the head start given the tortoise by Achilles is 10 meters. Use high school algebra to discern whether Achilles catches the tortoise. And what I mean here is solve the algebra. Number 2, reconcile quantitatively, that is numerically, your high school algebra solution with Zeno's parable, and which is known as Zeno's paradox. So what's going on here? And again, I'm asking you to reconcile this quantitatively. And question 3 is not dealing specifically with the Zeno, but it's a related concept. Consider a lamp with a toggle switch. Flicking the switch once turns the lamp on, another flick turns the lamp off. Now suppose that there is a being who is able to perform the following task. Starting a timer, he turns the lamp on. At the end of 1 minute, he turns it off. At the end of another half minute, he turns it on again. At the end of another quarter minute, he turns it off. At the end of the 1/8 of a minute, he turns it on again, and he continues thus, flicking the switch each time after waiting exactly 1/2 the time he waited before flicking it previously. The question is the lamp on or off after 2 minutes? And explain your reasoning. Last but not least, there were some students who were unclear about how to turn things in. So you go to our Blackboard shell, you go to LSA upload. Your step 1 is you click there, and that brings you to this area, and you will do a PDF upload to this. This will be your step 2 for the Zeno problem. You only get one chance to do this, though, so just take your time and do it right, please. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself, because self-care is important. And now more than ever, take care of each other, because we're all in this together. God bless you all, and I will see you in class.